Welcome to all of you. Good morning, all of you. Welcome back to the new semester, that is sixth semester 2022-23 academic year. I welcome you all and I wish you a happy new year. And I hope this year will have a prosperous happiness and happy life in your forthcoming year. Okay, welcome back to our semester, our course. That is, this is Dr. G. Ganesh Kumar, Department of Mechanical Engineering, working as an associate professor from the past 2008. And here I am going to deal with you a course called as heat transfer. Basically, the course code of this heat transfer is U18ME604. What's the purpose of this heat transfer course? It is to estimate the rate of heat flow of energy as heat through the boundary of the system under state and transient conditions, steady state and transient conditions, and to determine the temperature filled under steady state and transient conditions at each and every location. For example, you are having a plate like this, and if I want to have the heat is generated at this particular point, and if I want to have the heat distribution along the plate, then I have to make a heat transfer analysis to find out the temperature at any location throughout the plate. Such type of applications we generally used in electronic components called as vertical plates. The purpose of the vertical plates is to dissipate the heat from the PCB or programmable controllable board or motherboard. Okay, so that is one of the most important applications of this heat transfer. So how to make this heat analysis that we are going to discuss here in this session, okay, in this course, as well as we are going to discuss various applications of a heat transfer. Like the main application of heat transfer, just now I told the electronic cooling, heating of fluids, cooling of fluids, heat engines, nuclear power plants, thermal power plants, internal combustion engines, refrigeration and air conditioning units, heat treatment of metals, and heating and cooling of fluids. These are all the applications of heat transfer. Generally, all the applications, whichever you see from 1, 2, 3, 4, 5, 6, 7, 7 bullets corresponds to we make an assumption that the system is under steady state conditions. What do you mean by steady state condition? We will see more about this in future class. The steady state condition is nothing but there is no change in temperature with respect to time. Whereas the heat treatment of metals is to be studied in unsteady state condition because the heat transfer takes place rapidly. So from this we can say that if the heat transfer takes place rapidly, we should go for transient condition systems, and if the heat transfer takes place consistently or slowly, then we opt for steady state conditions. And how to make a steady state analysis, or how to make an unsteady state or transient analysis in heat transfer will be studied in this course. And now we just see what are the contents of this course, what is the learning objective and the course outcome of this course. The learning objective of this course is to study the modes of heat transfer, conduction, and external surfaces. So this unit will help you or develop you to get a knowledge on modes of heat transfer, conduction, and external surfaces. Whereas this course, once you complete it, you will able to analyze heat transfer, conduction problems of for various geometries. So in this chapter, you are going to discuss about an introduction, that is the basic modes of heat transfer, what are the governing equations of the modes of heat transfer, what is conduction, and what are the various types of conduction heat transfer through different geometries like cubical components, cylinders, spheres, etc. As well as we study the other topic called as extended surfaces, where we are going to discuss this is an application of a heat transfer. So for example, you might have seen an engine having a body on which you'll be having projections. These projections are nothing but called as extended surfaces. These extended surfaces are plays a very important role for various applications. And in this chapter in unit, we are going to study how to make an analysis of a heat extended surface, as well as what's the governing equation and how to apply this equation to various applications. Now coming to the unit 2. This unit will develop the student or you to get a knowledge on lumped systems as well as the forced convection heat transfer. Once you complete this course, you will be able to analyze the transient problems using lumped capacitance method, as well as you are able to solve the forced convection problems. And this unit will cover these topics called transient heat convection. In convection, we are going to cover heat transfer due to convection through external flow, where the flow takes place outside the geometry, and heat transfer analysis due to convection internal flow. Like for example, you are having a pipe. Through the pipe the fluid flows. Is it not? So when the fluid flows through the pipe, the heat transfer how to make an heat transfer analysis. The fluid flow is internal. Okay. Such type of heat transfer analysis you are going to discuss in this particular unit. Now coming to third unit. In third unit, you are going to discuss about free convection, boiling and condensation, and heat exchangers. Here, this will help you, or you will once you complete this course, you will able to analyze free convection problems, or you will able to solve the free convection problems corresponding to boiling and condensation, as well as you will able to design a heat exchanger. Okay, in this particular unit, we are going to cover a free convection where the convection occurs naturally. That means the heat transfer takes place without any external agency. Okay, coming to boiling and condensation. You might have seen at your homes you are boiling a milk. Is it not? What happens to when you boil a milk? What happens when you boil a water? What are the properties that are changed affecting the boiling process of a milk or water or whatever it may be? Any fluid. And also you might have seen a condensation. You might have taken an ice, place it on the table. After sometimes what happens to this ice? It undergoes heating process and it liquefies. Or you might have seen a fog forming on the glasses of the car when you are moving over the car, or when you are moving over the bus. The glasses are closed. The outside atmosphere is very fog, very snowy. Then what happens? The snow will form a fog. That fog is due to condensation. So what is the how to make an analysis of a condensation? How to make an analysis of boiling? Generally, the boiling is having very good applications in power plants, like boiling of water to generate a steam. Similarly, the last and very most important application in this particular unit we are going to discuss is heat exchangers. This heat exchangers, here we are going to make a thermal analysis of a heat exchanger, and also we make how to design a heat exchanger. So what is a heat exchanger? Heat exchanger is nothing but it is a use to transfer the heat from one fluid to other fluid when they are at different temperatures. When they are at different temperatures means one will be having high temperature, the other one will be having low temperature. The fluid which have high temperature we call it as a hot fluid, and the fluid which is having cold temperature we call it as a cold fluid. So here we are going to discuss about the hot fluid as well as cold fluid heat transfer when they come in contact with each other. Maybe indirectly or maybe directly. If they come in contact directly, then we call it as a complete then we call it as a contactless heat exchange taking place between the two fluids. But generally we don't go for mixing of fluids because the mixing of fluids will lose the sanctity of the heat fluid. The last and the fourth most important unit is fourth unit, where we are going to discuss a very important mode of heat transfer, that is radiation. We are going to discuss what's the mechanism of heat transfer due to radiation, and once you complete this course you will be able to analyze a heat transfer, radiative heat transfer between two bodies, as well as you will be able to understand the concept of the principle of a thermal radiation. Once you complete this course, you will be able to estimate this particular unit. You will be able to estimate the radiation heat transfer between the surfaces. And in this course, you are going to discuss various topics like thermal radiation, where fundamentals concepts of radiation with different laws, as well as radiative exchange between two bodies, radiation exchange between two bodies, as well as radiation shields. Radiation shields are very high are the applications of radiation, and there the heat transfer due to radiation plays an important role. And hence, we'll discuss only one component, that is radiation shields. And the textbooks. You are supposed to purchase this textbook, that is R.C. Sachdeva, Fundamentals of Engineering Heat Transfer, Heat and Mass Transfer, 5th edition, New Age Publications. And remember, I too have this soft copy of this book, and I will share this book in your coursework. Now coming to data book. This is another very important thing you should remember. C.P. Kodandaraman and S. Subramaniam Heat and Mass Transfer Data Book is a must for you to purchase, as well as the reference textbooks. This C.P. Kodandaraman and Subramaniam text data book you will get online also. You can take either printout or you can purchase. It's better you purchase it, that will be useful for you. And finally, the textbooks. Other reference textbooks are Pekenan, Heat Transfer and then Mass Transfer by J.P. Holman and Pekenan. These are the two important textbooks which you have to follow for this course. These are the course knowledge areas where you are going to gain once you complete this particular course. That is modes of heat transfer through conduction, transient and convection heat transfer, boiling, condensation as with heat exchangers, and radiation heat transfer and exchange of between different fluids. And the skill set you are going to develop by this particular course is you'll able to analyze different modes of heat transfer and conduction through different bodies. You'll able to evaluate transient mode and convection mode of heat transfer. You'll able to analyze boiling, condensation and heat exchange, as well as you'll able to explain the concept of radiation heat transfer between the two exchange bodies. And the qualities which you are going to gain once you complete this is academic integrity and honesty. You will able to gain effective judgment, as well as you will able to gain an ability to work independently and time management. Finally, the contents of this course web. There we have already had a course web in our website, and you all might have all got the link or connection or the access to the course web. So in this course web, I have uploaded all these things, that is course information, course syllabus, outcome based lecture schedule, table of specification, templates, as well as course discussion, topic summary, self-learning topics, unit-wise summary, course outcomes, handouts, and everything I am going to place. In addition to this, once the exam is completed, those examination papers also will be uploaded in this course web, which may be useful for you to utilize in final examination. Thank you very much. I welcome you all to the sixth semester, that is 2022-23, and I wish once again a very happy new year of 2020-23. All the best. Take care. Have a nice day. Bye.